All right, so the next types of problems are we want to solve the equations over the complex numbers. So that means we can take square roots of negative numbers and that works. And that means on the first one, what we can do is to solve this, I can say, well, I want to take the square root of that, and I want to take the square root of that. Now remember, when you take a square root of a number, it's going to be plus or minus. It's not just going to be the positive one. It could be either one. And so now I have x equals plus or minus the square root of a negative 25. Well, what do we know about that? Well, that's going to be equal to plus or minus. Now, that's the square root of 25 times the square root of a negative 1. Square root of negative 1, remember way back, is I, and we'll have our plus or minus here. Square root of 25 is 5, so that's equal to plus or minus 5i. Okay. Now, if we have to have it in the complex number form, that's 0 plus or minus 5i. Okay. Now, we can also solve it the other way. What we can do is we can say, okay, well, let's take and say add 25 to both sides. So x squared plus 25 equals 0. Now this, I can't factor. So guess what? We can use a quadratic formula. Okay. Now, that's going to be x equals a minus b. Well, where's b? Well, there's no b, so it's going to be 0. So I don't have to put a minus on 0. Plus or minus the square root of b squared, so that's 0, minus 4 times a, which is 1, times c, which is 25, all over 2 times 1. Okay, so what does that give me? Well, that gives me, 0 minus 4 times 25 is 100. So basically, that's gone. That's gone. So I have plus or minus the square root of negative 100 all over 2. Okay. Well, so what does the square root of 100 equal? Well, that's going to be plus or minus the square root of 100 times the square root of negative 1 all over 2. Now, the square root of 100 is going to be 10, so it's plus or minus 10. Square root of this is I all over 2. And guess what? That's just going to be 1, 5 plus or minus 5i. And again, when we get done writing it, we'd probably put it in the complex number form if that was asked for. Okay. So either way we do it, we get the same value. But the first way is special because we just had something simple that we could do. Now the second way is going to be more common how we're going to do this, because we might get something like this, which guess what? We can't factor really nicely. And so we're going to use our quadratic equation here to actually solve it. All right, so to solve it, x equals minus b, so minus 8, plus or minus the square root of 8 squared minus 4 times a times c all over 2 times a. All right, so that's a minus 8 plus or minus the square root of 8 squared is 64. 4 times 25 again is minus 100 all over 2. All right, that's easy. Now we're going to go up here because we're running out of room. So we're kind of going down. Now we'll go up here. And so that's going to be a minus 8 plus or minus the square root of, well, 100 minus 64 is going to be 36, and it's going to be negative all over 2. Now this is going to be done the same way as this up here, okay? And so maybe we'll just keep going right, and then we'll go below again. So negative 8 plus or minus the square root of 36 times the square root of I all over 2. And so that's going to be minus 8 plus or minus 6. Not I already put the number in. That should be negative 1. Haha. One step ahead, and then I put it in wrong. And square root of negative 1 is I. There's where the I comes in, divided by 2. Now, I'm going to break that up into two fractions. Then negative 8 over 2 plus or minus 6i over 2. And so 8 divided by 2 is 4, so it's going to be a negative 4. 6 divided by 2 is 2. And so that is going to be our value. Oh, 6 divided by 2 is 3, not 2. So minus 4 plus or minus 3i. So that's what our x's are going to be. So x is equal to a minus 4 plus or minus 3i. Okay, and so that would be our solution. And again, that was our solution up here. All right, again, this time the quadratic formula is going to be really the way to go as far as solving these equations. All right, so here it says use the vertex h comma k and a point on the graph, some xy, to find the general form of the quadratic function. All right, so basically what we're doing is we're using everything we've learned up to this point to plug in stuff, and then we have to find our function in whatever form they tell us. So in this case, the general form, but we could also find the standard form easily too, because that's really where we're going to go first, is the standard form, to be able to then square everything to get to that general form. All right, so what do we know about this? Well, again, that's hk, that's some point. And so what we can do is we can use our h and k to get to the function. And I'm going to write it just as an equation for now because I'm going to substitute x and y in. So I'm just going to write it as y equals, and then we're looking for a. And so that's what we have to plug in. And so then we have x minus a minus 2. So it's going to be x plus 2. Okay, and then that's squared, and then we have plus k, but k is -1, so -1. Okay, and now we can use this and plug that into this function. So this is really your f of x equals that. And so now we're using our function, our point that we know on the graph. So y is 3 equals a times x, which is -4, plus 2 squared minus 1. So let's go ahead and add 1 to both sides to simplify it from a little bit. So 4 equals a times. Now a -4 plus 2 is a -2. A -2 squared is going to be a 4. So, we could write this as a 4, or we could say it's a -2 squared. And so then we're going to divide both sides by a -2 squared. And so a is equal to that, which is going to be 4 over 4 equals 1. Okay, so that's what our a is. So we're back to our original function of f of x equals 1 times x plus 2 squared minus 1. So that's our standard form. Okay, now what we have to do is get to the general form, which means we have to square that and then subtract 1. Now, if we square that, remember, it's a perfect square, so we'll take the first number, square it, x squared, plus 2 times 4 times x, so it's going to be 4 to x. Square the 2, subtract the 1. So again, we're just taking x plus 2 equals x squared plus 2x plus 2x plus 4. And then that's 4x, and that's our 4x there. All right, so now then f of x equals x squared plus 4x. 4 minus 1 is 3. And that then is our general form. Okay, and that's what they wanted us to find. And so that would be our equation. Okay, so again, nothing hard. It's just plugging in things into formulas we know. We know how to get the function as an h and a k, and we have to solve for a. We plug in our extra point on the graph somewhere, and we get our a. And then after that, we just have to square everything and work ourselves down until we get to that general form. Now, if they said standard form, we're done right there. But they want us to go further and to get to that general form. Excuse me. All right, so let's pause there, and we'll come back with some applications.